Hey, I'm Ed Nielsen from the Power and Grounding team, and today we're going to go through a typical three-phase power and grounding audit. I have my trusty cameraman Don Davis behind the lens, and we're going to give it a go. So a couple of things to start with. This is a typical power and grounding audit. This cabinet right here is off. There's no power coming into it. If you guys get into a PDU or an A1 panel, you need to have your arc flash protection on, and a couple of tips. One, if your electrician is around, bring them in to help document the power path. Two, if you have a buddy, bring them in so while you're operating inside the PDU with your arc flash stuff, the other person can write down all the measurements while you take the measurements. All right, the forms are located on Support Central. That number is 16313. Typically you'll be getting these worksheets with any installation, but if you need them, look on Support Central 16313. I'm going to just go ahead and run through one, and let's go. So the very first section is going to be your admin section. Pretty much your system ID, your GON, your address, site name, etc. A couple of things to think about here. It's going to ask you for your modality and system model type. What's not written on these forms is if you have an X-ray system, you're also going to want to know what the kW rating of the generator is. So make sure and note that down. It's going to talk about UPSs. I'm not concerned about UPSs past this A1 panel. I'm concerned about UPSs that are upstream from it. It'll also ask if you have any power monitoring, like iSense units on there, or if any other kind of power monitoring. So the big key thing there in that section is write down your kW if you have an X-ray type of system. Let's move on to steps 1 through 4. It talks about the main disconnect panel. Main disconnect panel, the very first question, it asks for your main disconnect panel ID number. If the site actually has put some labeling on there, this is what that's for. So this would be panel HD. Next question asks about your main disconnect panel current rating in amps. For this site here, this is an older A1 disconnect panel. This is going to be 125 amp fuses, so it would be 125 amps. Typically, on all newer A1 panels, we're going to have a circuit breaker in there that has modules that can be replaced. So I brought one in. This is a 200 amp frame, but as you can see right down here, this little module can be replaced. So for a VCT it could be 125 amps, for an X-ray system it could be 70. In this example right here, it's an 80 amp module. So the correct answer to put down would be 80 amps. That's what's going to trip to protect our circuits and our conductors. All right, let's move on. If this is a GEA1 panel, let me know. There's a lot of questions inside here telling me the manufacturer, drawing numbers, catalog numbers, whatever it is. If it's a GEA1 panel, simply write it down, let me know. If it's something else like a breaker box, just a simple breaker box, write down Siemens squared E and the amperage of that breaker. Step 2, do the fuses and breakers meet the manufacturer's installation specifications? This is something you guys should know. 125 amps happens to fit the system that we're working on, so that would be yes. If you don't know that answer, there's a couple places you can take a look at. Your pre-install manual or your blueprints, your E1 and your E2 pages. Alright, step 3, is there an e-stop or emergency shutdown device readily accessible to the operator? Typically all that requires is the e-stop button on the console or the gantries or the tables. So if those are within reach, then you can check yes to this. It does not necessarily pertain to a shunt trip device. There's been a lot of questions in the past about that. It could be your shunt trip device, but it doesn't have to be the shunt trip. All right, verify your e-stop shutdown devices are connected and properly functioning. This is something you guys should be typically doing on your PMs and your installs, so I trust you'll have that done. All right, step 5 is the whole measurement of voltages. I'm not going to go through this one showing you how to do it. Everyone knows how to measure voltages. Basically, you're going to be looking voltages between the phase to phases, all of them, they should be balanced. All right. there should be no more than 2% differences between the low and the high. So on a 480 volt system, that's 9.6 volts. If I see a difference of more than 10 volts, then we're going to have some discussions with the facility. Going from your ground to your phases on a 480 volt system, that should be about 277 volts from ground to each phase. Again, those should be balanced also. Is there a neutral wire present? Now, there's no system in GE that uses that neutral. So you may have a neutral coming in, I'm going to show you up here, and it's not connected, but I still want to have the voltages between neutral and each of those phases. The reason is we can get some valuable information on the style of transformer, correct wiring, etc. Even though we're not using it, it's going to be good information for us to know. And the last voltage measurement is going to be between your ground and your neutral. All right, again, that gives us valuable information. Tells us the health of the system, the type of transformer we're looking at, etc. All right, we're going to run on to the next page. Panel currents. This is a section that most people are uncomfortable with. Typically in GE, we haven't been measuring currents, so we're going to go through a proper setup. All right, typical current probe. They go into the milliamp, red goes into milliamp, black goes into common. I've had very experienced engineers put them in the wrong plug out of habit. All right, so milliamp and common. This guy is 1,000 to 1 multiplier, so any readings that we get, we have to multiply it by 1,000, and we have to be on AC. So our phase currents, if you read the documentation, big red boxes on there says put it on the milliamp scale and put it on AC. So milliamp scale, some of the newer Fluke models will actually default to AC, but most of them are going to default to DC. In order to change it, you have to hit the blue button, check and make sure it says AC up there. If it is, you're good to go. You can measure all your phase currents. It doesn't matter where you measure them. You can measure them here, or you can measure them down here or across, whatever's easy access. Doesn't matter where you measure them, just wherever is easy. All right, now ground currents is a little bit different. Ground currents we're going to measure on the facility side of the A1 panel, and we're also going to measure on the load side of the A1 panel. We're going to take 2 measurements on each, so with power on and power off. To do that, again, read the big red box on your sheets. You're going to change it to microamps. That gives us more sensitivity. If you leave it on there, then the numbers are skewed a little bit. Same type of thing. By changing the buttons here, most meters are going to default back to DC. Take a look. Hit the blue button, make sure it's on AC, and away we go. So we have no power here, but theoretically, power is on. I would measure the facility side, ground. I would take the reading. I would then go on this side, take the reading, write those down. I would go ahead and shut the system power off. Now, system power off to the equipment, I would flip the breaker and I would retake those same readings. So facility side with power off and the breaker tripped. Load side, power off, breaker tripped. All right, that's going to give us some valuable information here, because basically we have one ground path from our equipment to this point right here, and that's going to be through our 1-aught ground cable. Here going back, you're going to have 2 paths. One is going to be your ground cable, but the other path is going to be the frame through the metal conduit back to the source. So there's 2 paths going backwards. All right, that's why we have to take multiple readings. All right, there's ground currents. The next part is panel wire size. So panel wire size. Finding the gauge of wire on here sometimes is difficult. I understand that these can be taped up, or all the numbers are rubbed off. Whatever it is, if you can't see it, then NA, not applicable, or just write down what what the problem is. Otherwise, trying to find the AWG in that long list of numbers is a little bit difficult. So here's an example. The number and the letter codes are much longer than this, but this is an example. Whatever it is, you find the numbers preceding the AWG, American Wire Gauge, and that's what we're looking at. It could be 8, 12, 16, whatever it is. This is 1/0. 1/0 is 1/0. Write that down inside there. All right, let's go back inside. Basically, we have 1/0 all the way through. All the phases, facility ground, load ground is all 1/0. All right, now we're going to talk about steps 8 through 17. Question 8. Are the facility and load grounds bonded to the panel, to each other, and to a non-painted conductive surface? Very important, because like I said before, we're going to have 2 ground paths going back to the source. All right, so in this example right here, you want to bring it on in there, Don. So they're bonded together to the panel through that nut right there, and to a non-painted conductive surface. This is a good example of how a ground should look. All right. Is a neutral isolated from ground? Well, let's move on up. There's a neutral. It is on an isolator, so that is good. All right. Can you verify that the connections are not loose, discolored, pinched on the installation? All right. This is going to be our tug test. So we'd go through with all power off, of course. Give them a good shake all the way through. This is something that most FEs don't do. So this side is all good. All right, question 11. Do the cable ducts have dividers separating power and signal cables? Inside your power conduit, you should only have your 4 or 5 wires, your 3 phases, your ground, and possibly your neutral, and that should be it. No other signal cables coming through. All right, in this case right here, down at the bottom, we do have some signal cables. So this would be something we would write up. All right, so has a power filter or regulator been installed? Step 12, there's a lot that can be there. It could be a old transductor, an old power tech. It could be a filter on a new vascular systems. It could be another style of filter. I've seen some filters from RadX. Basically, it's going to be a big box about so big, sitting upstream from the A1 panel. In this case, I know that there is nothing. It's all good. If there was one, we need the manufacturer, the amperage rating, and the location. All right, so can the panel be locked and tagged out? GE A1 panels, I have no issues with. Pretty much, yes, it can be locked and tagged out. Okay, is the ground run inside the same conduit as the feeders? This is an important question. So make sure your ground is run inside here, not run separate. If it is run separate, that's an NEC violation. Actually, the impedances get very high, and if we're running high current through there, it ends up looking like a toaster. It can burn up the conductors, cause heating issues, possible fire damage. So it's an NEC requirement. Step 15, are the conduits within the patient area metal? Basically, at this site, everything's good. So metal conduit, going to the PDU and whatever is all metal. Very good. No PVC. All right, step 16 and 17. They're designed for use with an impedance tester. If we can find the earth ground, we'll go ahead and do this. It's getting increasingly difficult to find these, find a single isolated earth ground and the tools. So most often 16 and 17 will not be answered. All right, the last section on page 2 is the environmental. If you guys have any issues with temperature, humidity, configuration, egress, whatever it is, this is your opportunity to put it down. And at this site right here, there's an issue with stuff in front of the A1 disconnect panel. If you take a look, you should have some room in front of the electrical panels. This site actually has a UPS right underneath it. So this would be your opportunity to go ahead and write stuff down that's saying, hey, it appears not to meet codes for access. All right, step 3, page 3. the most often ignored section. So this is documenting the power path. And when we document the power path, here's the intent, and I'm going to tell you the intent here. We are looking for loading, and we're looking for a transformer. So basically, if you use the analogy of a network system, the transformer would act like narrowing the bandwidth going to the equipment. So the transformer acts like a choke. If not enough power going to the equipment, you're going to have stress build up inside the equipment and eventually have problems with failures and whatever. All right, so let's take a look at everything that's feeding this site. If I go to the next panel here, it would be labeled H1. Tell me everything that's labeled on H1. So the site, we have a CT, an MRI, an X-ray machine, a VCT. We also have an elevator. All right, so this gives me an idea of the loading. How you would write that down would be in this section right here. So under device 1, we'd say it's a sub-panel. The name is H1. We have a CT at 90 amps. We have an MR at 90 amps. We have an X-ray machine at 70 amps, a VCT at 125. We also have an elevator that's 100 amps. It'll ask for the distance, which is approximated at 100 feet. The manufacturer of the panel is Square D, and the current rating of the panel is 400 amps. So that gives me an idea of what's going on within the facility. All right, so if you can go back to the next step, let's do it. Next step is going to be your main switchgear. Over here, we not only have H1 feeding it, but we also have H2, and we have a couple of transformers feeding this main switchgear. How are you going to tell me about this? Let's go over here to device 2. Okay, so this is our site's main switchgear. This is the name. Here are the loads. H1 is 400 amps. H2 is 400 amps. Transformer for MR1 is 100 amps. Maybe it's an isolation transformer. And then the transformer MR2 is another 100 ampere. And we also have a chiller on here. So there's the loads. Distance is 30 feet away from my other one. It's made by Square D, and the current of the panel is 1600 amps. Now if we go outside, and that's going to be the big key, that's where we're going to find the transformer for this site. There's a utility transformer out there. All right, we're 100 feet away from it. The kVA rating is 1000 kVA, and the transformer impedance is written in a percentage, 4.5%. All right, it's very important to get this if you can. Every single clinic or small facility is going to have a transformer either mounted on the ground or mounted on the pole. So finding this information and telling me the loads is going to tell us a lot. It's going to give us a story about the site and how well that equipment is going to be running. Basically submitting the data, there's a Support Central site you go to, and take everything you've written down, throw it on the Support Central site, hit submit, and away you go. So thank you very much. This is Ed Nielsen signing off.